Hello, in this video we'll be working through Unit 6 homework problems 56 through 64, and these problems deal with U-substitution. So 56, we're going to integrate x cubed times x to the fourth plus 3 cubed. Let's try letting u equal what we have in our parentheses, x to the power 4 plus 3. And if that's the case, then du dx is equal to 4x cubed. And if I multiply both sides by dx, I get du equals 4x cubed dx. So the purpose here is to somehow replace all the x's and the dx with some equivalent expression, but in terms of u, not x. So far we've got, let's see, x cubed and then u cubed dx. So I still need to get rid of the x cubed and the dx. So I almost have that here. I have 4x cubed dx. If I divide both sides by 4, I would have 1/4 du equals x cubed dx. So now I can replace the x cubed dx with 1/4 du. So 1/4 u cubed du. And now I've rewritten my integral in terms of u rather than in terms of the variable x. I can integrate this using power rule, so it becomes 1/4 u to the power 4 over 4 plus c, which is 1/16 u to the power 4 plus c. And then for our final answer, we don't want to leave u in our answer. We want to go back and replace u with x to the fourth plus 3. So I have 1/16 times x to the fourth plus 3 all to the power 4 plus c. Number 57, we want to integrate x times the cube root of 1 plus 2x squared. So we'll let u be what's inside the cube root, 1 plus 2x squared, and then du dx. Derivative of 1 is 0. The derivative of 2x squared is 4x. If I multiply both sides by dx, I get du equals 4x dx. And in my problem, I don't have 4x dx. I've got just an x dx here. So I'm going to divide both sides by 4, and I get 1/4 du equals x dx. So let's make our substitutions. The x dx becomes 1/4 du, and then we have cube root of u. Okay, so I've rewritten my integral in terms of u, and now I'm going to actually find the integral of this new problem. So 1/4 is a constant multiple that stays 1/4 times, and then the cube root of u, I can think of that as u to the power 1/3 and use the power rule. So it becomes u to the power 4/3 divided by 4/3, or times 3/4 plus c. So we get 3/16, and then u gets replaced with 1 plus 2x squared. So that's to the power 4/3, and then plus c. 58, x cubed times the sine of x to the fourth. What is our inside function? Let's let u be the x to the fourth that's inside of sine. So if u equals x to the fourth, then du dx equals 4x cubed, and if I multiply by dx, I get du equals 4x cubed dx. So I have part of that in my integral. I have x cubed dx. I don't have this 4. So if I divide both sides by 4, I get 1/4 du equals x cubed dx. And let's make our substitutions. So x cubed dx becomes 1/4 du. And the sine of x to the fourth becomes the sine of u. And now we integrate this, we get the integral of sine is negative cosine. So negative cosine u plus c becomes negative 1/4 cosine, and then u we're going to replace with x to the 4th. Number 59, we want to integrate x cubed over 1 plus x to the 4th squared dx. So we'll let u equal what's inside the parentheses, 1 plus x to the 4th, and then du dx equals 4x cubed, so du equals 4x cubed dx. And then we make our substitutions. So in the problem, apart from what I'm going to replace u with, so we'll have u squared on the bottom, but then I have x cubed dx, x cubed dx. So I want to divide both sides by 4. 1/4 du equals x cubed dx. Okay, so the x cubed over dx becomes 1/4 du, and then it's 1 over u squared. You can think of this as u to the power negative 2 and use your power rule, or you might remember the derivative of what is 1 over u squared. Well, the derivative of 1 over u would be negative 1 over u squared. So if we make this negative, then it's just 1 over u right here, plus c. So negative 1/4 times 1 over, and then we put this back in for u, so 1 plus x to the 4th plus c. And I'll go ahead and multiply that denominator, so 4 times 1 plus x to the 4th plus c, like so. Number 60, we want to integrate 5x times the square root of 1 minus x squared. We will let u equal 1 minus x squared. Then du dx equals negative 2x, so du equals negative 2x dx. Now when we go to make our substitutions, we have the square root of 1 minus x squared becomes the square root of u. Then I still have 5x dx that I have to get rid of, okay? And I know that du equals negative 2x dx. So I don't want the negative 2 there, but I do want a 5 there. So let's manipulate this equation a little bit. Let's divide both sides by negative 2. So I get negative 1/2 du equals x dx. I actually want 5x dx, so I'm going to multiply both sides of the equation by 5. And then I get negative 5 over 2 du equals 5x dx. So now I can replace 5x dx with negative 5 over 2 du. So I'll rewrite this now as negative 5 over 2 times the integral u to the power 1/2 du, and we'll use our power rule. We get negative 5 over 2 times u to the power 3/2 divided by 3/2 plus c. So negative 10 over 6 u to the 3/2 plus c is negative 5 over 3 times 1 minus x squared to the 3/2 plus c. (61) Integrate u squared times the square root of u cubed plus 2 du. Now, I don't want to say let u equal u cubed plus 2. Since this integral starts out with u as its variable, we need to choose a different letter. We can choose x if we want to choose x and just kind of do it in reverse, or you can choose w if you want to choose something different, or really any letter you like. I'm going to go ahead and just choose x. So we'll let x equal u cubed plus 2. And now the derivative of x with respect to u, so dx du equals 3u squared. And that means that dx equals 3u squared du. and I'm observing in the problem I have a u squared du. I don't have 3u squared du, so I'm going to divide both sides by 3 and get 1/3 dx equals u squared du. So we'll make our substitutions. The square root of u cubed plus 2 becomes the square root of x. And then u squared du becomes 1/3 dx. So we have 1/3 integral x to the 1/2 dx. And we can use our power rule here. So 1/3 x to the 3/2 divided by 3/2, which is times 2/3, plus c. So 2/9 x to the 3/2 plus c. But the original problem was in terms of u. So we need our final answer to be 2/9 times, and then we replace the x with u cubed plus 2. So u cubed plus 2 to the power 3/2 plus c. 62, we want to integrate x times the square root of 2x minus 1. So we'll let u equal what's inside the square root, 2x minus 1. And then du dx equals 2. So du equals 2 dx. And looks like we're going to run into a problem with this x right here. My du is only 2 times dx. It's not x times dx or 2x times dx. It's just 2 times dx. So when we go to make our substitution, that x is still hanging out there. We've got x and then the square root of u and then dx. And dx, if I divide both sides by 2, 1/2 du equals dx. So I can replace the dx with 1/2 du, but I still have this x here to get rid of. So we have to figure out, what does x equal? Well, I know that u equals 2x minus 1, so I can solve that equation for x. Add 1 to both sides, get u plus 1 equals 2x, and then divide by 2. So x is u plus 1 over 2. And that makes my integral u plus 1 over 2 times the square root of u times du. This 2 we can bring out. It gets multiplied by the 1/2 that's already out there, so 1/4 integral, and then we distribute the square root of u here. So u root u plus root u times du, or 1/4 times the integral of u to the 3/2 plus u to the 1/2 du. We use our power rule. So we get u to the 5/2 times 2/5 plus u to the 3/2 times 2/3, and then plus our constant c. And then we substitute back in for u. So 1/4 times 2/5 2x minus 1 to the 5/2 plus 2/3 times 2x minus 1 to the 3/2 plus c. (63) Integrate x plus 1 times the square root of 2 minus x. So we'll let u be what's inside the square root, 2 minus x, and then our derivative, du dx, is equal to -1. So du equals negative dx. If I divide both sides by -1, I get negative du equals dx. And I just did that because I don't have a negative sign in my original expression. So when we make our substitutions, we have x plus 1. The square root of 2 minus x becomes the square root of u. And then dx becomes negative du. So the negative is just means we're multiplying by -1, and I can bring that outside of my integral. Now I need to replace x plus 1 with something, or just the x, really just the x, with something. So I have to figure out what x is equal to in terms of u, and we'll go back to this equation, u equals 2 minus x, and solve for x. If u equals 2 minus x, we can add x to both sides, subtract u on both sides, we get x equals 2 minus u. So then I have the integral of 2 minus u plus 1, we can simplify that, times root u times du. So negative 2 plus 1 is 3, so 3 minus u times the square root of u times du, and then we want to distribute the square root of u there. So negative integral 3 root u minus u root u times du. And if we rewrite using fractional exponents or rational exponents, then we can use our power rule. So 3 times u to the 1/2 minus u to the 3/2 times du equals. And now I'm going to go ahead and integrate this. The antiderivative for 3u to the 1/2 is 3u to the 3/2 times 2/3 minus, and then u to the 5/2 times 2/5 and plus c. So our final answer, we're going to sub back in for the u, and here this 3's cancel out, so I get negative 2 times 2 minus x to the 3/2 minus 2/5 times 2 minus x to the 5/2 plus c. Number 64, find the value of the integral from 1 to 5, x over the square root of 2x minus 1 dx. So this is a definite integral. When we do a U-substitution with a definite integral, we have to change our limits of integration because the 1 is an x value and the 5 is an x value. We know because we're integrating with respect to x. So we're going to have to convert these into u values along with the rest of the problem. So let's decide on our u. We'll try u equals what's inside the square root, 2x minus 1. Then I'll take the derivative of that. So the derivative of u with respect to x is just 2. And if I multiply both sides by dx, I get du equals 2 dx. Now I don't have a 2, I have an x dx. I can see the x dx right here. I don't have the 2, so if I divide both sides by 2, I get 1/2 du equals just dx. And I can use that when I make my substitutions. So for my substitutions, my x dx, well, I don't have the x actually. So I gotta leave the x there. I have something that I can replace dx with. That's the 1/2 du. The x is still there. And then square root of u, since u is 2x minus 1. We need to get rid of this x here somehow. So let's go back to our equation for u and solve it for x. If I add 1 to both sides, I get u plus 1 equals 2x. And then dividing by 2, I get that x equals u plus 1 over 2. So our integral becomes 1/2 the integral u plus 1 over 2 over the square root of u. Dividing by 2 is the same as multiplying by 1/2. And multiplying by 1/2, I can bring that outside of my integral. And let me not forget my du at the end here. That comes down. So my 1/2 comes out. I have 1 over 4 on the outside. And now I just have u plus 1 over the square root of u on the inside times du. And I want to split this into 2 separate fractions, like so. And then I also have to figure out what my bounds are. Okay, so 1/4 integral u divided by the square root of u is just the square root of u plus 1 over square root of u times du. So let's figure out what our new bounds are. When x is 1, at x equals 1, and I'm looking back at this equation right here. When x is 1, 2 times 1 minus 1 is 1. U equals 1. So coincidentally, they're both the same. When x is 1, u is 1. At x equals 5, 2 times 5 is 10 minus 1 is 9. U equals 9. So for this integral, when I rewrite in terms of u, I'm not going from 1 to 5. I'm going from u equals 1 to u equals 9. Let's go ahead and integrate. So we have 1/4, and then the integral for square root of u. Square root of u is the same as u to the 1/2. So when I integrate, I get u to the 3/2 divided by 3/2 or multiplied by 2/3 plus, and then 1 over square root of u. I know that the antiderivative of 1 over 2 square root u is root u. I don't have the 2, but I can multiply this by 2 over 2, and now I have 2 times 1 over 2 root 2, so this is just going to become 2 times the square root of u, like so. And we're integrating from 1 to 9. So 1/4 times, now we're going to substitute 9 in for u. So 2/3 times 9 to the 3/2 plus 2 times the square root of 9. So all of that minus, and then we substitute 1 in for the u. So 2/3 times 1 to the 3/2 plus 2 times the square root of 1. Okay, 9 to the 3/2. Well, the half in the bottom tells us to take the square root. So the square root of 9 is 3. And then we have 3 cubed. 3 cubed divided by this 3 here is 3 squared, which is 9, times this 2 up here is 18. Plus 2 times the square root of 9 is 2 times 3, or 6. Minus, then we have to distribute this negative here. So minus 2/3 minus 2. So 1/4 times 18 and 6 is 24, minus 2 is 22, minus 2/3. So 21 and 1/3, or we can think of this as 66/3. So 66 minus 2 over 3, which is 1/4 times 64 over 3, okay, and then 64 over 4 is 16. So we have 16 over 3 for our final answer. And let's verify this on our calculator. If we use Math 9 with the original problem as it was given, so going back to the x's, we integrate from 1 to 5. And that original equation was x over the square root of 2x minus 1, all with respect to x. And that gives us 5.3 repeating. If we convert that to a decimal, 16/3.